current, electricity and its effects. Under that, we have already studied water resistance, and now we are going to study the factors affecting the resistance of a conductor. So the electrical resistance of a conductor depends on the following factors. That is, one, length of the conductor. The resistance R of a conductor is directly proportional to its length L. So that is R directly proportional to L. See, less length, less resistance, more length, more resistance. And second, area of cross section of the conductor. The resistance R of a conductor is inversely proportional to its area of cross section A. That is R proportional to 1 by A. Here it is shown two different cross sections. Here small cross sectional conductor, and it is bigger cross sectional conductor. So as per this, it is increased, the diameter is increased, then resistance is reduced by that. Nature of the material of the conductor. The resistance of conductor depends on the nature of material of which it is made. Some materials have low resistance, whereas the other have high resistance. It is because current depends upon the availability of valence electrons. If valence electrons are more for that conductor, then that resistance will be less. If the valence electrons are less, then resistance will be more. Effect of temperature on resistance. How the temperature affects the resistance. Effect of temperature on different types of material is discussed as follows. Resistance of a conductor increasing linearly with increase in temperature. So initially when you switch on that conductor, the current will be passing more, light or anything is brightly glowing. After some time, the conductor temperature is increased and current passes less. Because the resistance is increased, current is less. Then the brightness also reduces. So it means the temperature affects the resistance. Temperature increased, resistance also increased. Then resistance of semiconductor decreases with increase in temperature. But in semiconductor, the case is reverse. If the temperature of the semiconductor is increased, its resistance is reduced. Then resistance of electrolytes decrease with increase in temperature. Like the semiconductor, the electrolytes also same way. If temperature increased, resistance is decreases. Resistance of alloy increases with increase in temperature. From the above 2 points, that is 1 and 2, this 1 and 2, we can write R proportional to L by A, or R is equal to rho L by A, where rho is the constant of proportionality called resistivity or specific resistance of the conductor. Specific resistance means resistance of the material per unit length per unit cross sectional area. Okay, thank you.